Hello, everyone. I think we're good to start. My name is Pavel. I'm a product manager with AWS Mobile and the owner of Device Farm service. And we're going to spend next hour, talking about the service, hearing to real customer stories, and doing some cool demos. So welcome, everyone. Just before I start, quick show of hands. How many of you guys actually build mobile apps? All right, cool. How many of you test mobile apps? So I'm assuming most of you do kind of both. Very cool. All right, so let's get started. I'm going to start with a very quick overview of the service, some of the history, why we decided to do this. So developing mobile apps can be very, very difficult. You have to think about different hardware that the application will have to run on, right? And on Android side, especially, you have modifications introduced by different carriers as well as by different vendors. So it's not, when you're thinking Android 4.4, it's not always one and the same image of the OS, and then introduces issues. In addition to this, there are, of course, performance differences between devices. You have devices, cheaper devices in certain markets on the lower end, where application will not run as smoothly on some of the newer high-end devices, or maybe you'll even see problems with memory. This is what we often see with some of the game developers who cannot run on lower-end devices because bitmaps won't even load into memory. And this is why we decided to build a service. If your application doesn't work smoothly, you will end up with bad reviews. And bad reviews ultimately will hurt your business, right? Your application is most likely driving your revenue either directly or indirectly. Even if it's just about the brand, if you end up with a tarnished brand, it's going to hurt your business. So you don't want to put up in the market something that is not of top quality. And this is why we decided to build a service that helps developers to test their apps on real Android and iOS devices, not emulators, not simulators, but actually real hardware that is identical to the hardware and software used by your customers. And today, Device Farm supports two use cases. The first one is automated testing. In the automated testing model, you essentially upload your application, select devices you want to test on, upload your tests, hit go, and you will start seeing results trickle in within minutes, depending on how long your tests are. And we support a number of popular automation frameworks. I'm going to talk a little bit more about them later on, and we'll see some of that stuff during a demo as well. But we support Appium, we support Calabash, as well as options that are a little closer to the OS, things like instrumentation-based stuff for Android, like Espresso, or XC test-based stuff for iOS, like for instance XUI, KIF, or just plain unit tests written in XC test. So that's automation, and that's something that was with Device Farm since the beginning of the service last year. Earlier this year, we added another offering called Remote Access. And Remote Access allows you essentially to run manual tests on these real devices. The flow is even simpler than for automation. You essentially pick a device, and within minutes, you will see a screen of this device embedded in the browser, and you can interact with the device using clicks, swipes, and so on. You can install your applications. You can do anything that you would do on the local device. Once again, those are real physical devices that are hosted in our data center, not emulation or simulation. And I believe that later in the demo, we'll show you how remote access looks like. But you can go to the console right now, and it takes like 5 minutes to get started. So very easy. No code needs to be written in order to get started with that. A few more facts about the service. So like I mentioned before, it's both Android and iOS. And for testing, we support both native, hybrid, as well as web apps. It's really, Device Farm is really agnostic. We don't care about the type of the application that you're trying to test. It's more about the automation framework that you use. Some frameworks will support testing of web apps running in mobile browsers. Some of them won't. So it's all about the framework that you select. And like I mentioned before, we support many different frameworks. Today, we have over 300 unique device SKUs. And when we first launched the service, our goal was to cover about top 80% of both Android and iOS market. And back then, we were able to do this with, I believe, around 250 devices. We've been adding devices since then. Today, we are over 300, and our market coverage is is even better than it used to be on the day of the launch. I didn't mention this, but our initial focus was US market. Since the initial launch with US-based device fleet, we also have been adding the devices from other international markets like China, India, and we just started adding devices that are specific to certain European markets. While we have only 300 unique SKUs, there are many, many instances behind each and every SKU. So behind every single unique SKU, and by SKU I mean make, model, and OS combination, there are many instances, both for redundancy and capacity reasons. So some devices are more popular than others, and they receive more test volume. Some devices may be more flaky than others, especially lower end ones. So they may crash in the middle of the test, they may drop Wi-Fi connection and so on, and they spend more time in maintenance mode, so we have more of those, so you can always test on these devices. Another interesting aspect of the service is security. Just like for every other AWS service, security is paramount, and we spend a great deal of time when we're first working on a service to make sure that that's also the case for Device Farm. And first, the way we manage our data center, the way our infrastructure is built is that devices are isolated from each other, both on the software and hardware level. Let's start with the hardware part. Devices are essentially mounted in special canisters in our data centers that provide both physical and radio isolation. Every single device will have its own dedicated access point. So if you're running tests on one device, you will not be able to see what other customers are doing on other devices and vice versa. These boxes also provide physical isolation. That means that if you're using a camera, you will just see within the box. You will not be able to see what's happening on other phones that are literally, running customer tests next to your phone, and it's all tightly packed in our data center. But again, the physical separation aspect makes sure that it's all safe and secure. And this isolation aspect propagates all the way up through the stack. So every single device has an EC2 instance associated with it. These EC2 instances are not reused. Every time you get a device, you get a fresh instance of EC2 that gets torn down after you're done with a test. And of course, all of the networking between the device and that instance is also secure and isolated from other devices. Like I mentioned before, we support a number of frameworks. So we support both manual and automated testing. And within automated testing, there's lots of flexibility, lots of choice. Some of the most popular frameworks that we see are Calabash and Appium that allow you for cross-platform test writing, or at least you can have a single set of tools for both Android and iOS testing. We also see a lot of interest around frameworks like Espresso for Android or XCUI on iOS recently, and we of course support these frameworks as well. And we continuously look at the market or the open source community, and as we see new frameworks emerge and become popular, we'll be adding support for them as well. You'll see this later on during a demo, but both for manual and especially automation, we provide very rich reports for what happened on a device. So when you schedule your automated tests and you wait for a few minutes for results to come back, you will see full device logs, for instance, Logcat on Android or devices log on iOS. You will see screenshots if your tests capture any screenshots. You will see video captures, which we collect automatically. So for every single test, you will see a complete video capture of what happened, performance data, actual test logs, and more. Reports give you pretty much access to all of the data possible that can be collected from devices. In addition to this, if you collect some proprietary data, maybe you create your own log files, you can also just upload it to S3 and just print more information in the log, and parse it out later. So there are also ways to incorporate your custom data to the reports and access this later on via the API. Finally, Device Farm integrates with a number of other tools. So everything that you can do with Device Farm is available via the API, which can be accessed with AWS SDK or CLI. That means that you can integrate with any tool of your choice for continuous integration or continuous deployment. We do have some of these integrations included or available out of the box. One of them, the most popular one, is of course Jenkins, and we have a Jenkins plugin that takes like 5 minutes to install straight from Jenkins. And we'll show you this to you today during a demo. And in addition to this, we have integration with Gradle, which is part of Android Studio. So some integrations are available out of the box. Other ones you can build yourself, and we have a number of customers who did integrations themselves simply because, again, it's all available. Both reporting as well as scheduling is available as a part of AWS SDK. An important differentiator and something that is special about Device Farm is that by default you pay just for what you use, so there's no need for a longer-term commitment. There is you can just pay by the minute. Of course, as your usage grows, it kind of makes sense to get into a different pricing scheme. But by default, you can pay just for what you use. And speaking about pricing, just a quick overview. By default, you pay 17 cents per device minute. So for instance, if you have a test that runs for 10 minutes and you schedule it on 10 devices, that will be $17 for a run like this. Of course, if you're running, doing a manual session on a single device and you, for example, try to reproduce a customer issue, it takes 10 minutes, it would be $1.70. The moment you start running big continuous integration, continuous deployment test loads, it makes sense to look at the second pricing scheme that we offer on our public cloud, which is device slots. And with device slots, you pay a flat monthly fee that allows you for unlimited testing at a given concurrency. So if you get just a single slot, it will cost you $250 per month. You can run as many tests as you want, but we'll run them on up to one device at a time. You can still schedule your test run on 20 devices. It just means that we'll run them one by one. If you want to run on 20 devices in parallel, you have to get 20 slots, right? But of course, you can start just with one. So this gives you essentially unlimited testing at a fixed rate, and you're just buying concurrency. You're just buying bandwidth, and it's a great way to keep your bill under control if you're doing CI, because if you're doing nightly builds on 10 devices, maybe you don't care for all 10 to run at the same time. Maybe you're doing this build every 3 hours. So maybe you start with, I don't know, a couple slots, maybe 3 slots, maybe 5 slots, depending on how much testing do you do. Similarly, on the remote access side, where you do manual testing, it's kind of like how many team members you will have doing manual testing at the same time. If it's 5 slots, and they can run as many tests as you want, and you don't have to worry about the minutes. Important thing, we also offer a one-time free trial. Device Farm doesn't have a free tier like some of the other services, doesn't have a recurring free tier. We have a one-time free trial of 250 minutes, and you don't have to do anything to ask for this trial. When you first start to use it, you just get it automatically, and it applies to any offering, both automation and manual testing. I talked about some of the use cases, reproducing customer issues, maybe running one of test automation. Of course, one of the most popular use cases for Device Farm is continuous delivery with something like Jenkins that I talked about before. So it's very easy to integrate. With Device Farm with Jenkins, provided that you already have tests written in something like Appium, Calabash, Espresso, or XCTest, depending on what you're really trying to automate. And this is the main use case that we see with our customers. And there are thousands of developers that trust Device Farm already. Some of the names are immediately recognizable. Customers like Allstate or Etsy, as well as Gannett. And actually, I have Greg with me here today. He's a senior engineer with Gannett, and they've been our customer for I think more than a year right now. And he's here to talk a little bit more about how they use Device Farm, how they connected it with other parts of their DevOps infrastructure.
Thanks, Pavel. So I'm Greg Seipel, senior engineer at Gannett. I'm responsible for test automation infrastructure, test coverage, and continuous integration across all Gannett products. So USA Today starts with the iconic USA Today, which is national news and also leads into 109 local media organizations across the United States. You may recognize some of these local markets up here on my slide. We provide rich media content through hundreds of outstanding digital, mobile, and print products. But the most important piece of our company is we have a really deep reach to where we have over 100 million unique users accessing content from the USA Today network. So the evolution of testing at Gannett started at this really slow crawl where everything was a manual process. Then we graduated and learned how to walk, and automation was introduced. So now we're actually physically running, and that process is repeatable and disposable. We're hoping next year we'll be able to introduce Docker containers to where we can move even faster. So 2 years ago, everything was a manual process for us. It took us weeks to build, test, and deploy our mobile apps. We're not talking about one app. We're talking about 110 markets times 2 for Android and iOS. So the common problem with a manual process is something always goes wrong. And it typically will happen maybe before or right at the beginning of a testing stage. So this typically results in everything starting over and results in many iterations till you find a release candidate. This process is repeatable, but it took us 4 to 6 weeks to get one release candidate out the door. So a year and a half ago, automation was introduced from automated testing and continuous integration tools. So now we're moving faster and reducing some of those iterations between developers and test automation to release apps faster and get it out to the market. But now the problem was we was moving too fast based on our on-premise continuous integration architecture. We only had a couple Jenkins servers with a few executors. So 6 months ago, we had the opportunity to make a change. And that change started by expanding our on-premise architecture for iOS and moving Android completely to a cloud disposable infrastructure. This completely will remove some of our bottlenecks. Starting with Android, the key to continuous integration is to ensure that you automate the whole entire cloud infrastructure to be disposable. But the next really key piece is making sure you're testing everything, from your infrastructure code all the way to your functional UI tests. So 6 months ago, we started down this path to make this change, how to build, test, and deploy our Android apps. So let's take a few minutes to review some of this architecture with our Android in the cloud architecture and how we were, to where we could use some of the DevOps tools that we use throughout this whole process. This new architecture allows us to build and test every pull request into GitHub, and we're able to scale as many Jenkins servers we need to build 110 Android apps concurrently today. So starting at your top right is Chef. We use Chef to download, install, and configure Jenkins and our Android SDK on the servers in the cloud. We use Scalar to manage all of our servers in the cloud, and Scalar sits on AWS. But what Scalar really allows us to do is it's an easy way to bootstrap our Chef cookbooks and control our costs. I'll touch on this a little bit more later, how we actually use these two. In the very bottom right, to manage all of our different artifacts for all of our markets, we're using a tool called Artifactory. Artifactory is our central hub for all of our artifacts built from our continuous integration pipeline. On the top left of our diagram here is our backup storage. Every night we store a nightly backup of our Jenkins server to ensure if anything ever goes wrong, we can restore from that backup. At the very bottom, we're using AWS's Device Farm. It's an app testing service that allows us to test and interact with physical devices in the cloud. At the end of every test run, we are able to access logs, screenshots, videos, performance data on all the devices that was there. The important piece is that it gives us a good opportunity to understand if it's a bug or it's an actual, a particular change, or like Pavel was talking about, it could be a particular device that has some performance issues. But the core piece of this whole architecture is in the center. As you can see, Jenkins is our continuous integration tool of choice. But the main piece that makes this whole thing drive forward is our repeatable and disposable infrastructure of our Android Jenkins slaves. We have the ability to spin these up on demand anytime we want and tear them back down when we're not using them. Outlining and monitoring all of our architecture, we're using Datadog. We're able to aggregate all of our logs and events on a rolling timeline. This information can be used in many different ways. The first way we're using is to monitor Amazon EC2 servers based on CPU usage, how much bandwidth we're using on it, memory, etc. But the second piece that we're using it for is KPI, key performance indicators. This allows us to measure our continuous integration pipeline based on pass fail rates, how long it's taking, or other little things that we have in there that gives us those indicators how we can improve moving forward. So every time we commit code or there's a merge from a pull request, this synchronizes to our continuous integration pipeline by using GitHub webhooks. So this whole new architecture has allowed us to build, test, and deploy 110 Android apps within less than an hour. So let's take a closer look at our continuous integration pipeline. So as you can see, the first three stages are automatically triggered when some type of activity happens on GitHub. It could be a creation of a pull request, or it could be a merge with a pull request into the master. The last two stages are still somewhat of a manual process, and I'll go a little further into that in a second. Let's take each of these stages and start the first one, the checkout stage. It detects if there's a creation or a merge of a pull request. It'll execute a shallow clone of the GitHub repo on our Jenkins slave. If this stage passes, then the pre-checks will fire off next. The pre-checks will build all of our markets, run our unit tests, our API tests, and then push all those artifacts to Artifactory if all the pre-checks pass. The third stage is the acceptance stage. It retrieves the necessary artifacts needed to push up to AWS's Device Farm. Typically, it's the Debug APK, and it's all the Android APK. It then will run all of our espresso tests against a predefined device pool. The fourth stage is our exploratory stage. It's an optional stage. We don't execute it all the time. But part of that acceptance stage is automatically also push the artifacts that pass to App 47. App 47 is our sandbox for the App Store. It simulates if you're going to the Play Store or to iTunes. Anybody can go in and download those artifacts. They can access the remote access with using AWS's Device Farm and test push notifications or upgrades. The last stage is our App Store stage. It marks all the approved artifacts that pass during the pipeline, and we're able to push those by a manual push release. At the very last piece, we use Slack for notifications. So anything that goes wrong during this whole process or everything that goes right, it notifies us in a Slack channel. So developers can understand what pull requests could possibly broke the build, or also what test broke the build. So Chef. Why Chef? Chef allows us to automate the entire infrastructure code to be repeatable and disposable. At Gannett, we use two types of cookbooks. I'm going to do a high level of the two we use. We use a utility cookbook and then a role cookbook. The utility cookbook, we're just downloading, installing, and figuring something on the server. The role cookbooks is what all the teams use in the sense of it's a bunch of includes of other utility cookbooks to where we can customize it based on what attributes we want to pass. So to take a closer look at our Chef Jenkins, the cool thing about this is we're able to, when we converge a server, we have a choice to download the latest Jenkins WAR file from a stable build or their weekly release. But the other piece that is really important is we can specify a particular version if we wanted to. We also can restore from our backups. So anytime we respin our Jenkins server, we can retrieve the latest backup. We didn't lose anything. Or we can also scale up the new Jenkins from scratch. The other things that automatically happen in this process is configuring LDAP, so people can log in, get the right credentials, admins, people with read-only access. You also can download and install Jenkins plugins based on your project. But the last and most important piece of this whole cookbook is the Jenkins swarm. We can automatically connect our Jenkins slaves to master when they come online. So if we spin up 27 new servers, when they come online and we're running hundreds of tests or builds at the same time, it starts distributing all that across the new servers that came online. When we're done building and testing, we can tear them back down. Our Chef Android SDK, when it converges, it does a few things. It'll go download the Android Studio. Then you're able to download based on what platform SDKs you need to use, build tools, etc. If you're only supporting API 21, 22, 23, you can specify that in this cookbook and only deploy on that server. We also download the Android key stores from a Chef data bags. And lastly, we also set the environment variables and permissions on the server. So when this is completely converged, it's like an operating computer like at your desk. We can repeat this process, and this is disposable. So cloud management. So Scalar is our cloud management platform. What is Scalar? So Scalar farms are a logical grouping of configured farm roles. If you want to create a server, you need at least one farm role. You don't need a farm role for every server, but you need a farm role for each type of server. So in our case, we have a farm role for Jenkins and a farm role for Android SDK. Also part of this process, we can size our machines based on what we need. So for us, we will size the machine to where it can have X amount of executors on it. So to kind of get that understanding of what I'm talking about, how we configure our farm roles. So we can choose what operating system we want to use, what instance types we use. In this case, for Jenkins, we're using a T2 medium, and this is based on how many CPUs you need to use, how much RAM you need, disk space, etc. For the Android SDK, we have found that M4 extra large has been the best instance type for us to have 4 executors and run 4 builds or 4 tests concurrently on that particular server. We can also add what necessary security groups. But the most important piece of this is how we can easily bootstrap Chef to our farm roles. So AWS's Device Farm. There's a couple reasons why we picked Amazon's Device Farm. The very first one, they support our mobile testing frameworks that we use. So we're using Google's Espresso for Android and Google's Earl Grey for iOS. The second reason is we wanted to test against physical devices. And as everybody knows, devices are released every few months, and trying to support that yourself, it's a high cost. And by kind of testing using AWS's Device Farm, it helps us control that cost a little bit. So when we use AWS's Device Farm, we're using the Jenkins plugin that Pavel mentioned earlier. We select a predefined device pool, which is based on what devices we want to test against and what operating systems we want to use. Then it fires off all of our Espresso tests. If we're doing 10 mobile devices, then it's going to fire off 10 tests across that on the physical devices. Device Farm supports iOS, Android, and Fire devices, and also a wide variety of different operating systems. The bottom graphic, Pavel has mentioned, this is the remote access. This is where you have You can remote into a physical device from your web browser. You can interact by doing swipes, any type of gesture you need. We use this for a couple ways. Exploratory testing, and we use it if we found a bug or a possible failure in our automated testing. This gives us an opportunity to get onto the device and try to see what went wrong. So iOS. The challenges with iOS, really, iOS development, is you have to build on Apple hardware. There's no way around it. And so the way we've got around it is by using the direct connector. This allows us to have this hybrid architecture to where we can establish a connection to our on-premise Mac mini farms, to our AWS's ecosystem. Now we can easily add new hardware as we needed to whenever we decide we want to go faster. Currently, we can build, test, and deploy 110 iOS apps in about less than a day because we only have about 5 Mac minis right now. So what's next? We want to continue to be proactive, continue to find ways to be better, move faster, and build quality apps for Gannett. Our next piece that we're going into 2017 is Apple Tools. When you start doing functional UI testing, the one piece that you miss from manual testing is that visual aspect. And so Apple Tools, what it does is, as we're running our functional UI test, we can take a screenshot. It'll create a baseline, send it up to Apple Tools, and then the next time we run a test, it takes another snapshot and then does a diff between the two. It will tell us if there's going to be if there's any physical differences with those two images. The only piece that's somewhat manual is now you got to determine, was that a failure by design or is that an actual bug? Docker and Kubernetes are our next kind of technology we like to use in the sense to where we can use containers to help us reduce the time to spin up our servers. Right now, Chef takes us about 15 minutes. We're hoping when we get into the Docker and Kubernetes, we can be maybe in the 2 to 3 minute range. So we're saving some more time, also controlling that cost. New Relic. It's another way to where we can monitor our servers and send out alerts. This will allow us to understand if something went wrong on our servers. And it really keys into the last two things I'm going to talk about, status page. Status page will allow us a better way to communicate when there's downtime or we want to schedule maintenance on a server. And the last one is VictorOps. It enables us to really resolve issues faster and minimize the actual impact time of the whole infrastructure being down. And in my last slide, we're always looking for top talent to join our DevOps team and our developers in test. Thank you. Pavel?
Thank you, Greg. This was very, very helpful. And before we move to a demo, just real quick, what's new in Device Farm? We are about to launch some stuff. There's some stuff that we just launched. I'll kind of walk you through the most recent changes. So fast, just right after reInvent, we're about to launch a feature called Network Shaping. It's actually ready and staged, just should be live next week. What network shaping will do is it will allow you to define the network conditions for your test. So you'll be able to define the bandwidth, jitter, delay, and packet loss, both up and down. So 8 parameters total. That will allow you to test your application under network conditions that are similar to, for instance, carrier network conditions that your users might encounter. So things like, hey, how my application behaves in lossy 3G network conditions. And you'll be able to pre-select profiles, but also you'll be able to define your own profiles. Those are the screenshots from our scheduling wizard when you can actually see where you can either pick a profile or define additional parameters. So we're super excited about this feature. It's been asked by customers for a long time, and I'm really happy that we're able to deliver this right now. The second thing that I'm announcing today is private devices. So everything that I talked about before is public cloud. So it's essentially fleet of devices that are shared between customers. Of course, not one device by multiple customers at the same time, but it's essentially time sharing. You get a device, you do your stuff either manually or automatically, we clean it up, and then another device will get this device at some point and their job will be done on that device. With private devices, you essentially can get dedicated hardware instances that will never ever be used by anyone else. And it's not just devices that are dedicated to you, it's actual hardware that we use to host them, hardware that I talked about before. So it's a private dedicated hardware, you may want to do this for a few reasons. The obvious one is stuff that we don't do on a public cloud because it might be a little bit too exotic for us at this point. So maybe things like you want to test on rooted OSs, which we generally do not support in the public cloud, for instance, cyanogen mod or something like that. Or just weirdo devices or maybe even special devices that are not available to the public that you would like to deploy to our cloud and test on them, you can do that as well. Another reason why you may want to consider doing the private devices is additional compliance and privacy, right? So like I said, on a public cloud, we do cleanups before and after every test run. But certain organizations need to know that no one else will ever touch a device where your data was deployed. And with private devices, you actually get this guarantee and you can get this compliance. Additional thing that you can do with private devices is customization of configuration. So things like, I already talked about rooted devices, but things like, hey, what if I want to pre-install certain apps on a device and just keep them there, keep these applications on the device so you don't have to do this every time you run your tests? Or what if I want to pre-configure a device with large amount of test data on the external storage, and again, keep it there, do not have to do this every time because it just cuts in your test execution time if you have to do this on a public cloud. So those are some of the things that you can do on a public fleet. And pricing is somewhat similar to deviceless that I talked about. It's based on a monthly subscription. You pay a flat fee per device instance per month with a minimum subscription of 6 months. The reason why we have minimal subscription of 6 months is that we will buy a brand new device for you, and after you're done with the device gets destroyed. Essentially, it will never leave our data center intact and will be shredded. So that's on private devices. The last one before I hand it over to Ilya for a demo is we just completed a redesign of our console. We added a bunch of features earlier this year, and things were starting to look a little cluttered, especially since we added video, and we made a big push to improve the experience so it's much easier to look at the logs, video, screenshots, and other artifacts in one place. And we just launched it before reInvent last week. And you will be able to see these improvements in the demo in a few short minutes. And I'm handing it over to Ilya for the demo part.
Thank you. Thank you, Paul. I'm just going to connect here. Okay, awesome. Thank you. My name is Ilya Epstein. I'm a solutions architect with AWS. I work primarily with enterprise customers, but I also focus on AWS mobile services. So one of the top questions that customers usually ask me when we talk about Device Farm is how do we integrate this with our continuous integration pipeline? Gannett already spoke about that a little bit, and I'm going to do a demo of that. Now, for the purpose of today's demo, we're going to be using Appium framework. So we're going to look at some of the Appium tests. We're going to use our code commit, which is an AWS service for source control. And then we're also going to use Jenkins with the AWS Device Farm plugin. But as Paolo mentioned, really the same concept really applies to any tools that you have. Everything that you do in AWS, as always, is driven through API. The Device Farm Jenkins plugin, for example, is open source on GitHub. So if you want to integrate this with any other frameworks that you may have as part of your continuous integration pipeline, you could do so. So let's take a look at some of my tests. So I have a set of tests here in Appium. The way Appium is organized, for those of you who have used it, right, there's concept of pages as well as tests. Pages are basically your UI components and instrumentation of how do you interact with the individual screens. And then you basically package that for your test, you basically string them together and then you create your functional test. So what I'm going to do is Just to be able to make a change in code and commit it, I'm going to just go ahead and make a small change. I'm going to actually take a screenshot here. And this is actually another question that always comes up from our customers is how do you, does Device Farm support screenshots? Sorry. And the answer is yes. Any screenshot method that you use within any testing framework is supported by Device Farm. What we will do is during runtime, if we need to replace the directory where the images are stored so that we could go ahead and pull them into your reports, we will do so. But you could basically use whatever approach you use for taking screenshots within your application. So I'm just going to call it subheader here. And just going to change it. So I made a change here, and for the purpose of the repo here, as I mentioned, I'm using AWS Code Commit service. AWS Code Commit is a fully managed source control service, which allows you to deploy private Git repositories in a highly secure and a highly scalable manner. And it's fully integrated with any Git tools that you may have. So for example, if you're using eGit with Eclipse, right, it's fully supported. It's 100% compatible with Git. So in this case, I'm just going to go ahead and do a commit. And I'm going to save it. And I'm going to do commit and push. Okay. Oh, sorry. Problem with live demos, right? Let me open up. So I'm going to move over to my Jenkins server here. Now, this Jenkins server is deployed on an This Jenkins server is deployed on an EC2 instance. And I'll talk about the benefit of actually deploying Jenkins on EC2 as well from a security perspective. So the way I have here is basically a simple Maven project. I'm using Maven in this case to go ahead and do my build. If I look at the configuration of this Maven project, I want to point out a couple of things, right? So one thing is you could see that this is integrated with Code Commit. Now, the nice thing about AWS Code Commit is it actually it's fully integrated with IAM, which is Identity and Access Management, for control of who gets to check in and check out of that repository. And the nice thing is if you deploy something like Jenkins on an EC2 instance, there's a concept of EC2 instance profiles, right? Which means that an EC2 instance could actually assume a role and get temporary credentials. So that in this case, I don't actually have to manage my credentials for Code Commit. I'm actually able to go ahead and use the EC2 temporary credentials, which are automatically rotated for me to be able to securely access my repo, right? So this is just a nice benefit of using some of the integrated services on AWS. In this case, I'm doing I'm polling the repo, but you could also do, webhooks like you do in GitHub. That's actually, preferred. You could do something similar with Code Commit as well. And then here we have the plugin for Device Farm. Now, how does this plugin work, right? So basically, this is where you configure the different components, the configurations for your test run. And as you can see here, this is actually a post-build action, right? So you could actually have multiple post-build steps in your pipeline, and one of them could be Device Farm. The first thing that you select here is a project. A project in Device Farm is basically a workspace where it's just a container for all of your different runs. You also have device pools. As Powell mentioned, Device Farm has hundreds of different devices, but you could organize them into different pools. So for example, if you have Android tests that you're running, you may just have a handful of Android devices, right? If you're running iOS tests, it'll be iOS devices. We also have some curated pools. We call it top devices, right, which you could use as well. You could also use your analytics. It's actually encouraged, right? So if you have analytics in your application, you could see the top devices that your customers are actually using and go ahead and create a device pool for those specific devices. You also then configure the actual application, right? And this is, it's either the APK file or IPA file in iOS. This file could actually be part of your, depending on the workflow that you have, part of your test projects could include the actual APK file, or you may have a different work stream, right, that puts the APK file or IPA file into Jenkins and maybe a separate process. It really depends how your teams are organized and how the QA teams are really interacting with the development team. You could run these tests on metered or unmetered devices, right? So the unmetered device would be device slot. So if you do have device slots, you could actually run that against the device slot as well. This is a really nice feature, is you could store the test results locally. So in a second, I'm actually going to log into the AWS console and show you how you could use the AWS console to see the reports and the status of your test. But you may have use cases where you want to get all that information, including screenshots, and integrate it with other testing data that you may already have. You may want to create your own custom dashboards, right? So you could do that. You could actually have Jenkins pull in all the results directly on that box. And then, of course, you configure the different testing framework that you use. So once the test is kicked off, I want to go into a build that I have here. And you can see here, the plugin actually will give you a high-level status of your tests, right? So 145 tests. There are actually 145 individual tests as part of this run, based on the suite that you saw in Appium. 145 of them passed. 5 of them had failures. And this is, you could start making a determination, right? Do you want to pause your deployment, or do you want to address this, right? You could determine whatever threshold you have. If it's just warnings, maybe go ahead and continue with the deployment pipeline. If it's critical failures, go ahead and investigate. Now, the nice thing is, with a click of a button, I can actually go ahead and launch the AWS Device Farm console, and it actually takes you directly into the run for that for the one that was scheduled. The console, we made a lot of great, I think, enhancements on how to navigate the console. So the first thing is we show you are the unique problems. And this is really great because customers want to be able to see what are my top issues, right, across different devices. If it's something that's happening across multiple devices, I may want to address it. If it's something that's only specific to one device, maybe I'll investigate it separately. So it gives you a count of the devices and a count of errors and which specific devices that occurred in. If I scroll down a little bit further, you can actually see all the devices that were used as part of this test. So you could see I was using the top devices device pool, and in this case it had 5 devices. A couple of devices didn't have any errors, right? But 3 of the devices had some errors. If I want to go ahead, and by the way, you could see that some of these devices, these are real carrier devices, right? Some of them are OEM, but a lot of these are non-rooted, carrier devices. And it's very important, right? Because an Android, for example, from AT&T sometimes has a very different experience, from another carrier. If I drill down further, I'm able to go ahead and see all of the test suites for that device. Now, a suite is basically a collection of your tests, right? And the nice thing that we added very recently is that I could go ahead and go into any test and click on it, and it will play back the video of the test as it happened, right? And the connection here may be a little bit slow. No, it's working. So I'm just going to forward a little bit. So here's my app. You can see it's launching. It's going through the test. And I have step-by-step video of actually what happened. Right? This video is actually an artifact. Again, you could download this artifact as well, and you could analyze it further. If I scroll down further, I could actually see the different suites. And within suites, right, you may have a single test, or you could have multiple tests. And let me go down to one that had an error. So if I want to go a little bit deeper and actually pull up a suite that had an error, I could pull that up as well. Again, I could play the video for that error just to see what happened on the screen while that error occurred. And then, I could go a little bit deeper and actually get the error log for that test. Now, the nice thing is we have we expose all of the logs that are available right in the single console. So the harness logs to prepare your test, the actual logs from your testing framework, if it's Appium or Calabash, whatever it is, we have it here as well. And then, of course, the device log as well. So, like Lockcat from Android, for example. It's really easy to search. If I want to just search for an error message, right, I could just pull it up and see the exact error that occurred. The nice thing is I could also scroll down and actually see performance metrics. And this is important, right? We actually capture CPU utilization, memory utilization, as well as the thread utilization for that duration of that test. Some of the network stuff and network shaping information that Powell talked about, we're going to introduce this in the console as well as we make that available. And then, of course, all of the files. So you can actually go ahead and download all of the files right here. Or again, if you're using a continuous integration model, you probably just want to pull those log files directly into Jenkins. And then screenshots, right? The screenshots are purely driven by your testing framework, right? We don't automatically take screenshots, but if you included screenshots in your test, then they will show up here as well. So one thing I want to show you is, let's say you had an issue with that continuous integration test, and you want to investigate it further, right? So the nice thing is, like we mentioned, we have this feature called remote access. So I could go ahead with a click of a button and start a session. So, you know, as you mentioned, right, there's sometimes you want to investigate a specific issue. Is it really a problem? Maybe it was a device issue. So I think I had a Samsung tablet that had a problem, or a Note. I could just go ahead and select it. And it's just that simple. I go confirm and start a session. It'll take a few minutes for that device to be available, and I'll show you that in a minute. One other thing I want to show you is, let's say you have QA teams that maybe they want to do a test even with, let's say, Appium or Calabash, but they don't want to do it through the continuous integration pipeline. Maybe they just want to do kind of a quick ad hoc test. You could do that as well. So I could go into the project, and I could create a new run. With that, as part of that run, you could see I could upload an Android APK file or an iOS IPA file. We also support, by the way, web applications as well. This testing doesn't have to be limited to native apps. This is also very useful for web applications as well. In this case, I'm just going to do a quick upload. I have an IMDb file here. And by the way, I encourage you, like, you could just go home, do an extractor of any APK file that you have running on your device and actually just do a quick test, right, and see how it works. I'm going to select that device. I'm going to click Next Step. So this is where you could select, very similar to what you saw in the Jenkins plugin, but here you could do it natively in the console, right? So I could select all the different tests that we have, Appium, Calabash, instrumentation testing. We also have something called built-in Explorer testing. This is very useful, right? Let's say you don't have, maybe you're not yet using an automation framework, and you just want to do some basic sanity checks on the application, right? So we have two types of built-in tests. One is called an Explorer test. The Explorer test actually will try to understand the layout of your application. Even if it has a login screen with a username and password, it could actually log in. And actually try to navigate the app as much as possible. And then we also have a built-in fuzz test, which will basically just randomly click on your application and see if it crashes, right? In this case, I'm just going to select the built-in Explorer test. I'm going to click Next. Here's where you could configure which device pool you have. And Powell said that we have hundreds of devices. I just want to give you an idea, so you can actually see it for yourself. These are all the different devices that we have, right? And you could do a quick search, and you select, which platform you want. So maybe iOS. And you could see it's dozens and dozens of devices with different types of OS available for you. Once you select which device pool you want, so maybe I'll select my Android one and click Next. There's some interesting options that you could configure. So one option is you could add extra data. This is very helpful. Sometimes your application needs some data to interact with. You could actually upload that data, and it'll be a prerequisite before the test will run. It will actually download that data to the device, right? And then your application could interact with that data. You could also install other applications. Let's say your application interacts with maybe a social media app, maybe Twitter or Facebook. You could actually install those other apps as a prerequisite before you run your tests. So you could actually install other apps as well. You could also set radio states. This is very helpful, right? Because you want to be able to test your app. How does it behave with no Wi-Fi or with Wi-Fi or GPS or whatever it may be. You could also specify the device locality, right? So if you want to test how the device performs in different areas, just change the longitude and latitude. And of course, you could change the locale as well. Once you select all of that, you basically are ready to confirm your run and click confirm, start run. And from this point, it's exactly the same thing, right? So whether I have this automation test running or whether I have a manual test running, I have the same exact console experience to be able to navigate and look at the screenshots, look at all the logs, and so forth. If I just go quickly switch back here, I think I have it in a separate screen. I thought I had my remote session. Oh, you know what? Might have closed it. And anyways, I wanted to show you quickly the remote session, but I think it got closed. The remote session is basically you just go ahead and launch a device that you want to interact, and you just literally could just swipe on it, click on it, and interact with it in any way. I think that's basically what we wanted to cover. I definitely encourage you, just try it out. 250 minutes are free, so play around with it and see how it works. And I think with that, we're going to conclude the demo. I'm just going to quickly switch back here. Please complete your evaluations. We don't have time to take questions from the podium, but from Mike. But if you just, we're going to stick around for a few minutes. So if you guys have any questions, please come over. And thank you.